Good morning, students. Welcome to class on Monday. Hope you had a good weekend and hope that you're counting the days down little by little. Looks like the last 9 weeks just ended, and now we're starting the last as in the third 9 weeks, and now we're starting our last 9 weeks. So for you three seniors, congratulations. Hang in there, keep working. You're almost done. And please don't cash in early, okay? We have a lot of math to do and a lot to do this week. Quite often I have a little schedule up for you on Mondays of the whole week. I'm not going to do that today. I'm just going to tell you that we're doing a lesson. We're going to skip a couple lessons, 8.3 and 8.4, and come back to those on Wednesday. So we're going to do 8.5 today, 8.6 on Tuesday. Wednesday we're doing 8.3 and 8.4. They're really, really easy lessons. It's almost kind of review of middle school math, area of triangles, rectangles, and squares. Pretty easy. And then we'll finish up the chapter on Thursday. Now, if we finish up the chapter on Thursday, we will have a test. Well, I'm getting a little ahead of myself, so I'll just stop right there and tell you. Then on Friday, we're going to start a review sheet. I'm actually going to give you a couple days to work on your review sheet because we're doing so well on time. That'll make you have a little less work at home and allow you to get a little more work done in class. Okay, let's go over some announcements. You will have a quiz this Wednesday. Usually you have quizzes on Friday. You will have a quiz this Wednesday. I'm doing that for a couple reasons. A, I want to keep Friday open for a review sheet, and B, I want you to not have as big of a quiz this time. The quiz grades were not as good as I wanted the last time, so I'm going to try to make the quiz cover a little less material. So a quiz on Wednesday. There'll be a test next Tuesday. So keep all of that in mind. You owe me Friday's homework, so please get that out now. That should have been lesson 8.2. So please get out Friday's homework. And let's see, Tara, you were supposed to take a quiz. I'm making this video on Saturday night, so I've not yet gone to church on Sunday and gotten the work. So hopefully you've taken that quiz. If not, we'll talk more about it on Tuesday. And then Ashley, you missed a test last week. I will give you until Friday. That's 5 days. That's plenty of time. So you have until Friday to make up your test. Remember, students, I am a phone call and an email away. Okay, so it is your job to contact me if you have any questions at all. So Tara or Ashley, if you don't feel like that's sufficient, just talk to me and we'll go from there. But if I don't hear from you, test by Friday. There's my phone number, and my email is like anybody else at Berean. It's earhartm@bereanacademy.net. Okay, let's see. Let's go over your test. Now, I need you to be women of integrity. First of all, in just a second, I'm going to ask Ashley to leave the room. So, Ashley, please do that. Go somewhere where you cannot hear what I'm saying. Ladies, you will get out your test then. They should have been passed back to you already. And let's go over your test. When I'm done with that, you will then go get Ashley. You'll turn your test back into Mr. Harmon. You will not speak to her about the test, and she will take the test by this Friday. Okay, so go ahead and pause the video, and then when Ashley has left the room, go ahead and restart the video. Okay, here we go. Have your test out, please. Everyone turn on your test to number 10. Some of you missed this, some of you did not. So here we go. Here's problem number 10. All right. The perimeter of a rectangle is 70 feet. The ratio of the length to the width is 4 to 3. Find the length and the width of the rectangle. So what I would encourage you to do on your test was draw a rectangle like this. And then the ratio of the length to width is 4 to 3. I'm going to call, sorry about that, let's fix that real quick. I'm going to call this an X and put a 4 with it, that's the length, and then put an X here and put a 3 with it. That means I'm compensating for the different lengths or the different measurements by using 4 and 3. Now if this length here is 4x, then this length here is 4x. If this length is 3x, then over here we have 3x. Now I did that because the ratio is 4 to 3. All right. Well, if the perimeter is 70, I'm going to add up all the sides. So 4x plus 4x plus 3x plus 3x Now, if you did not miss this, please don't zone out. Okay, there's going to be some problems you did miss, so hang in there. Okay. Kate had the highest grade on the test, by the way. I think she had 100, so congratulations to her. But Kate, you still did miss some, so make sure you're listening here to the ones you missed. Okay, 4 plus 4 is 8 plus 6 is 14x equals 70, and then divide both sides by 14. X equals 5. Now, it's not your final answer. I want to know the length and the width. So the length is 4x. Where the x is, I put a 5. So 4 times 5 is 20. And then my width, where the x is, I put a 5. And 3 times 5 is 15. So there's the length and there's the width. All right, moving on to this problem here. Would you please look at 16, 17, and 18? Some of you missed those and some of you did not. 16, 17, and 18. And I don't have a test in front of me. I'm going to have to get one real quick. Okay, number 16 says find the value of y. Find the value of y. So here's y right here. And obviously y goes with this side over here. So I'm going to say 6 over y equals. Now guys, I can't use 15 because 15 goes with a variable. I can't use u and 6, that's a variable, but I can use 9 and 6. So I can say 6 over y equals 9 over 6. Okay, let's cross multiply. 9 times y is 9y, 6 times 6 is 36. Divide both sides by 9, and y equals 4. Y equals 4. So I'm going to come up here, if that's okay with you guys, and cross this off and put a 4 right here. That's going to be helpful later. All right, number 17 says find the value of z, the value of z. So obviously 15 and z correspond, so I'm going to say 15 over z equals, and I'm going to use the same two sides, 9 and 6. So 15 over z equals 9 over 6. 9 times z is 9z. 15 times 6 is 90. Divide both sides by 9 and z equals 10. So I'm going to come over here and cross this off and put a 10 right here. Now remember, if I'm going, I go fast on purpose because you cannot speed me up, but you can always slow me down by pausing the video, so it's your job to do that. 18 says find the ratio of the perimeter of these two polygons. Now, no one missed number 15. And if you look at number 15, it says find the value of u. And everybody got that right. The value of u was 9. Okay? So, come on, students. This really isn't that hard. I mean, find the ratio of the perimeter to the perimeter. So, what's the perimeter of this object over here? Well, it would be 24 plus 15. This perimeter would be 39. If I add up all four sides, I get 39. All right? Over here I would get 16 plus 10, I would get 26. 26, okay? Well then, obviously, what is the ratio of the perimeter of PQRS to TVWX? Well, it would be 39 over 26. Now, I think I gave you full credit if you had that, but you really should have reduced it. 13 goes into both of those numbers, so your ratio is 3 to 2. All right, hope that helps a little bit. Again, I go fast. You can always pause the video. Let's take a look at number 20. Number 20, I'm simply asking you, are these two triangles similar? Well, I'm going to very quickly draw the little triangle right here, and then the big triangle right here. And then quickly I'm going to put in this little triangle 63 degrees here, and then 63 degrees here. Now, do you notice how they share the same angle? This angle right here, I don't know what it is, but I know this angle here is congruent to this angle here. So for those of you that missed this, yes, these two triangles are definitely similar. Yes, similar. By what reason? Angle, angle. We learned 3 different ways to prove that triangles are similar. Angle, angle, side, 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 and side, angle, side. And so if 2 angles in one triangle, right here, are congruent to 2 angles in another triangle, then the triangles are definitely similar. Okay? All right, the next one that some people missed was number 21. Now what I'm going to do is I'm going to draw the top triangle. Well, actually, I'm going to leave it right here. I think I'm going to take this. Can I slide this? All right, that's not going to work. Okay, let's just leave it like this. Notice I have Remember when two lines intersect, their vertical angles are congruent? We've talked about that many, many times. And so this angle right here is definitely congruent to this angle here because we have two lines intersecting. So look what we have. We have side, angle, side. And over here we have side, angle, side. And so the only thing we need would be the sides to be proportional. Notice our angles are congruent. The side angle side theorem states if you have congruent angles and the sides that connect the included angle, if those sides are proportional, then we have similar triangles. So I could say this side right here, 14 goes over 7, so 14 goes over 7. This side here and this side here equals, and this side here would go over this triangle here, or this side here, 14 over 7. Well, if you reduce both of those, you get 2 equals 2. Or if you want to say 2 over 1, that's fine. So yes, definitely. Yes, triangles are similar by side, angle, side, most definitely. All right, let's continue on. We have a lot of notes to take still yet today. All right, number 23, same thing. I'm going to very quickly draw the front triangle right here, and then the bigger triangle right here. And there we go. All right, now notice I have a length of 15 here on the little triangle and a length of 21. Now the big long length right here, this big length right here, would be 20. Hopefully you can see that, 15 plus 5. And this whole bottom length down here would be 28. Okay? Now notice they do share an angle. This angle here is congruent to this angle here. It's the same angle right here. So once again, I might have side angle side. Let's see. 15 corresponds with 20, and that would equal 21 corresponding with 28. Reduced by 5 over here, you get 3/4. Reduced by 7 over here, and you get 3/4. So I have side angle side angle side in such a way that the angles are congruent and the sides are proportional. So yes, similar, side angle side. Okay, for those that missed number 25, please pay attention. Number 25. Okay, first of all, notice how we have this line here intersecting this line here, and whenever two lines intersect, their vertical angles are congruent, so I know this is 45. Now, I'm going to add these two angles together over here, 45 plus 70, and that gives me 115. I added these two angles here together. And now I'm going to subtract from 180. And when I do that, I'm left with 65. So this angle right here has to be 65. Okay, so let's see. I subtracted 180 minus 115. I got 65. Now look at what we have. I have two angles right here in one triangle, congruent to two angles in another triangle. So yes, again, I have similar triangles by angle, angle. Okay, and now let's take a look at number 26 on your test. Notice I have side angle side, angles congruent, angle is congruent. So let's see if we have proportional sides. 10 over 6 equals 24 over 8, and there's no way you're going to get equivalent fractions. You will get 5/3 equals 3 over 1. So no, these sides are not proportional, thus we do not have side angle side. All right, now here we're trying to see if this line here is parallel to this line here. Now, the way we're going to do that is we're going to see if we have proportions. We're going to say 7 over 18 equals 8 over 20. Now, if you reduce these two fractions, 7 over 18 would not reduce, and 8 over 20 would reduce to 2/5. Okay? And that's not true, so you would say QS is not parallel to TP. All right? And now let's take a look at this last problem before we get into today's notes for a little bit. Same thing. Is QS parallel to PT? Well, the only way to know is if we have proportional sides. There's a theorem that we learned about that. So I'm going to say 4 over 8 equals 1 over 2. If you reduce 4/8, you get 1/2 equals 1/2, and they're definitely equal. So yes, QS is parallel to PT. All right. Okay, that's it for the test. Please pause the video. Please hurry and get Ashley back into the room. We got to take notes right away, so please get her quickly. Grab your notebooks, and we're going to try to whip through this lesson so that you have some time in class, hopefully to start on your homework, so it's not all done at home tonight. So please quickly pause the video, get her, then restart it. Okay, hopefully you've done that. And we're going to take some notes now for a little bit, so please grab your notebooks and write this heading down in your notes. We are looking today at finding areas or finding areas of parallelograms and rhombi. Finding areas of parallelograms and rhombi. It's lesson 8.5, and the date today is the 11th. Okay, the 11th. Now, very quickly, as you're copying this down, you do not need to take notes on this, but just remember, the other day we went over this. You should now be able to look at two different parallelograms and tell me which ones are concave and convex. This one here would be convex. This would be concave. You should be able to do that. You should be able to look at any convex polygon now and tell me the sum of all of the angles added up, the interior angles, all of the sum of the interior angles by counting the size. And we learned this formula right here, 180 times n minus 2, n being the number of sides. So any convex polygon I give you, you should be able to find not necessarily each individual angle, but the sum of all of the interior angles added up. So you should be able to do that. In fact, if I were to give you all of the angles like this, we'll call this 100, we'll call this 95, we'll call this 95, we'll call this 130. If you were to add up those four angles, you should be able to find this missing angle here. We'll call it x, because this formula here would tell you all of the five angles, their sum, what their sum would be, and you could add these four angles up and subtract from that number and find that angle. So I'm just reviewing very quickly. You really should be able to do all of that. And then very quickly, just one more thing that we did learn, and that would be, and that's not what I wanted to do, so please bear with me for just a second here. Thank you. All right, you should be able to also, let me get a pentagon up here. Remember how we said if all of the sides, if all of the angles are congruent like this, and that would be an equilateral polygon, then you really could find the measure of one of these angles. You could find the sum of all five angles, divide by 5, and you would know that angle. So that's some of the stuff that we did learn last week. You should be pretty familiar with that, and if not, go back and watch videos, review your homework, whatever you got to do. Okay. All right, today we're going to look at finding the areas of parallelograms and rhombi, lesson 8.5, and the date today is the 11th. Okay. On a parallelogram, and I would like you to quickly copy this in your notes, please. On a parallelogram, if I can get this to work, there we go. Copy this in your notes. This is what we call the base right here, okay? So make note of that in your notes. This bottom side here is called the base, all right? And this side right here is not the height. Please don't miss that. That is not the height. The height is the distance. When we say what's the height of the parallelogram, we mean this line that comes straight down right here and forms a right angle. Or sometimes you'll see the height drawn on the outside like this. They'll draw a line straight down outside the parallelogram and then draw a line straight over. This is the height. Now your seniors and one junior, take notes however you need to make note of that. But the base is the side that runs parallel across the bottom. The height is the length that is perpendicular to the base. It goes straight up and down. Every year students become confused and they think this is the height right here and this is not the height of the parallelogram. So please understand that and make note of that. Now, it's really neat on how how you find the area of a parallelogram. It is so easy. Would you please write this in your notes? Are you ready for this really difficult formula? It's base times height, and that's it. It's very, very simple, okay? We're finding the area of a parallelogram, and you simply take the base times the height. Now, I'm not going to spend a lot of time on this. Obviously, it's very easy. In your notes, I would like you to copy this parallelogram in your notes, please. And I'd like you to label, I'm going to put a dotted line going down, and I'm going to label that height to be 8, and I'm going to call the base going across 15, and I want you to find the area of that parallelogram. I'll give you a second to copy this down. A parallelogram with a base of 15 and a height of 8, and I want you to find the formula. Okay, the formula obviously states a base times height. So in order to find the area of this parallelogram, I'm simply going to take, actually I should put the 15 first, I guess, to be consistent with the formula. So base is 15, height is 8, and 15 times 8 would be 120. So your answer is 120. All right, it's just that easy. All right, now I'm going to throw some at you here and let you earn some easy bonus points to help you out on your quiz. Before I do that, I do want to take a second and I want you just to sit back, relax, and watch this. I want to show you why this formula works. Okay, so you do not need to take notes on this, just watch. This is just a little extra. Okay. Okay, here we go. Here's a parallelogram, as you can see. Now just kind of ignore this line right here if you would please, okay? But here's a parallelogram. And any true parallelogram that you have, if you were to take a pair of scissors or whatever you would need and cut this side or this corner piece off right here and move it over here, look at this. Isn't that cool? Now my drawing's not perfect, you know, but it's close enough. Look at that. See how it fits? And now you have a what? A rectangle. And we know from, my goodness, elementary school how to find the area of a rectangle. It's this length right here times this length right here. And what is that red line? That's the height. And what's this red line? The base. And so that's why all of that works, just so you know. This is a parallelogram, and if you were to cut this side off right here and drag it over, you really have a rectangle. Okay, you do not need to know that. It's something just to think about. Okay, I want you to copy this in your notes. I will wait a second while you do that. The blue part, I'm going to actually outline the parallelogram for you. This is the parallelogram right here. I'm outlining it in red. Would you please copy that into your notes? Please copy that into your notes. And let's find the area of this parallelogram. All right. Let's find the area of this parallelogram. And actually, I'm going to have you do this for a bonus point. So go ahead and find the area of this parallelogram for a bonus point. Do not pause the video. I'm going to let this run. And just kind of wait for you guys. Now remember, you need a height. Okay, I will say that. You need a height. And it's okay for them to give you the height out here. That's totally normal. Okay, so the base is pretty obvious and the height is pretty obvious. Okay, you should have the answer by now for one bonus point. To find the area of a parallelogram, you take the base times the height. The base is 9, the height is 6, and your answer is 54. It really is that simple, students. It really is. All right, let's kind of turn things around. I'm going to pause for a second. I want you to copy this in your notes. I want you to write this parallelogram in your notes, or draw this parallelogram in your notes, please, just like this, if you would. And I'll pause while you do that. And then go ahead and draw a line straight down and call that H. And then notice I'm giving you the base. I'm also giving you the area. I'm actually telling you the area on this parallelogram, and I want you to find the height. We're looking for the height. So take a second, copy this down. Okay, let's find the height of this parallelogram. Well, let's use our formula. Area of a parallelogram equals base times height. Now I can make a substitution for A because I know the area is 48. That was given to you. For B, I can make a substitution of 12. Is that not the base right there? 12 all the way across. And then the height, of course, is just h. Well, we know from simple algebra 1 now to solve for h, I would divide both sides by 12. And when I divide both sides by 12, I get 4 for h. So there. Sometimes I'll give you the area, I'll ask you to find the height or the base. Sometimes I'll give you the base and the height, then I'll ask you to find the area, okay? So the answer is 4. Now for one bonus point, and you're on your own on this, I want you to find the height of this parallelogram. Do not pause the video, I'm just going to let it run. I want you to go ahead and for one bonus point, find the height. You do not need to write the parallelogram in your notes if you don't want to. You can if you want to, but I want you to solve for h for one bonus point. Keep working. I'm just going to ramble while you're working. I'm going to go ahead and write the formula up here. Just keep working. Okay, I'm going to start filling some things in now. Obviously, I know what the area is. It's 72. I know what the base is. It's 12. And the height I don't know. We're going to divide both sides by 12, and 6 is your height. 6 is your height, okay? I'm probably doing an amazing, hold on a second, did not mean to do that. I'm probably doing an amazing overkill here, but let's go ahead and try one where I ask you to find the base, okay? So here's your parallelogram. Here is your base. We're going to call that B. And then here is your height right here. So now I've given you the area, as you can see. I've given you the height, as you can see, and I want you to find the base. All right. So I'm going to go ahead and keep working here. You can just draw the picture quickly and fill things in quickly. We really got to hurry on here. So area equals base times height. For the area, I substitute 486. For the base, I simply leave it B. And for h, I put 27. Now look, students, even though it's b27, that's the same thing as 27b. So I'm going to go ahead and divide both sides by 27. And when I do that, I will get 18. All right? So 18 equals b. There, you found the base. All right? All right, let's keep running bonus points to help out your quiz account. I want you to find b. All right, now you need the area, and I've got to kind of look that up and see why I left that off. Okay, here it is. I apologize for that. Area is 30. All right, so there's the area. It's 30, and the height is 5. I want you to find the base of this parallelogram. All right. For one bonus point, just let the video run. I'm going to be quiet while you guys kind of work on this. So we're looking for the base. All right, I'm going to go ahead and write the formula down. I'm going to make a substitution here, bring down my B, make a substitution here, and this would be your answer right here. Divide both sides by 5. All right, that was for one bonus point. Okay. All right, well, let's continue on. Okay, let's take a look now at finding the area of rhombi. Okay, and as I paused the video a second ago, my wife was giving me a lecture. She said that she's sitting here laughing. I think this word is pronounced height. She said it's pronounced height. And I don't know. I've never walked and said my height is. I don't know. Anyways, Okay, moving on. You know, men always have to win an argument. All right, we're going to look at the area of rhombuses, or rhombi actually. And here's the formula. We're going to look at how to find the area of a rhombus, and this is really, really cool. Please write this down. Do you know how you find the area of a rhombus? It's 1/2 d subscript 1 d subscript 2. Isn't that cool? Do you know what D stands for? Please make note of this. The diagonals. A rhombus has two diagonals. So one of the diagonals goes here, the other diagonal length goes here, and you multiply all these together. Now at the end of the video today, contain your excitement. I know you're on the edge of your seat with excitement, but I'm going to show you where this formula comes from. All right? But let's go ahead now and take this formula. Let me quickly cut it and paste it. Let's take this formula and let's apply it to this problem here. So would you please take a second and copy this? Did not want to do that. Please copy this. Did not want to do that either. This rhombus in your notes. Would you please do that very quickly? I'll pause while you do that. And let's find the area of this rhombus. All right. Let's find the area of this rhombus. Okay, hopefully you've jotted this down. You know, it's kind of interesting. You say, Mr. Air, I don't see any diagonals. Well, I know, but look, if I drew a diagonal here, do you see how there's a length of 10 right here? So that means this diagonal right here is 10. And if I drew a diagonal going straight down like this, do you see how they gave you a length right here that's 14? Well, that means this whole diagonal right here is 14. So they're always going to give you the lengths of the diagonals. They have to, okay? So I want us to find the area of this rhombus. It's so easy. Area equals 1/2 times one of the diameters, we'll say 10, times the other diameter, which is 14. Well, if you use a calculator, that's fine. I don't mind that. You would get 70. The area is 70. Ladies, it's that easy. Okay? If I ask you to find the area of a parallelogram, it is base times height. Base times height. If I ask you to find the area of a rhombus, it is 1/2 d subscript 1, d subscript 2. Let's take a look at another one, okay? Would you please quickly copy this in your notes? Quickly copy this in your notes and let's find the area. I'll pause just a second while you draw this quickly in your notes. Okay, we can see that in order to find the area of this rhombus, we would have 1/2 times, are you ready, 18 times 12. Because look, if from here to here is 9 and here to here is 9, then the whole diagonal is 18. And if from here to here is 6 and here to here is 6, then the whole diagonal is 12. So there we go. And the answer to that would be 108. If you take 12 times 18 and then multiply it by 1/2, you will get 108. All right. I think we're running out of time to give you a proof on why this formula works, and I'm sorry. That just happens sometimes. We spend a lot of time on going over your test. So for a couple bonus points, and if you've got your 5 points, I want you to do these anyways. You don't have to copy this down in your notes if you don't want to, okay, the actual picture, but I want you to find the area of this rhombus for 1 bonus point. Find the area of this rhombus for 1 bonus point. Don't forget to draw an imaginary diagonal right here, and you should be able to tell how long that is, and draw an imaginary diagonal right here. All right. I'm going to wait a second while you find the area of this rhombus for 1 bonus point. Okay, hopefully you should know that the length of this diagonal is 18 because you've got the length right here, and hopefully you can see the length of this diagonal here is 15 because of this here. So to find the area of this rhombus, it's 1/2 times 15 times 18. And the answer to that would be 135. 135. Of course, you can use calculators if you want to. One more for one more bonus point and we're finished for the day. Please find the area of this rhombus. You can copy this in your notes. If you don't want to, you don't have to. The main thing is work this problem or solve this problem for the area of the rhombus, and that'll be worth one bonus point. Okay, I'm going to go ahead and write the formula down. Hopefully you're still working on it. I'm going to start filling this formula in, so if you're not finished, do not look up yet, please. Okay, you should by now see that one diagonal has a length of 10 and the other diagonal has a length of 28, 14 plus 14. So if you do all of your work correctly, the area equals 140. And of course, for all these problems, we could say square units. I really wanted to get into an explanation of this formula. I will just simply say this very quickly. I will not belabor the point, but look, if I asked you to find the area of this triangle right here, remember how to find the area of a triangle? It'd be 1/2 what? Base times height, correct? And then over here you would have 1/2 base times height plus, in the area of this triangle, 1/2 base times height, and then you could factor out the 1/2 and you'd have your base and height plus base and height, but the two b's are the same and the two h's. I won't get into all that now, but it's pretty easily proven why this formula works. We're just running out of time on that today. So thanks for your listening today. Here's your homework. There will be a video on this. The video will always be, the first three words are always Berean Academy Geometry, you know that, and then it will say 8-5. Now we skipped some lessons, okay, so it'll say 8-5, and then it'll say homework, okay, just like it's done all year. And here's the homework, so please copy this down. It's page 442, numbers 8 through 13, comma, 18 through 20, comma, 23 through 28, and I believe that's 12 through about 15 problems, I believe. So page 442, 8 through 13, 18 through 20, 23 through 28. Have a great Monday. If class is not over, please get started on your homework right away. If you need to watch the video, watch it. And you know what, ladies? You got to turn your homework in, because this coming Friday, whatever's not done is, I told you from now on, no making it up unless your absence is going to be 0. So get this done, please, okay? Thanks and have a good day.